Hello students, welcome to our exciting Arduino class. Today's project is called Fire Alert Display. We will learn how to use a flame sensor with an LCD display using I2C module to detect fire and show messages like fire detected or safe on the screen. Components required. To build this project, we need Arduino Uno, a flame sensor, a 16 by 2 LCD display with I2C module, few male-to-male and male-to-female jumper wires, a breadboard and a dumb cable to upload code. What is a flame sensor? A flame sensor is a device that can detect fire or flame using infrared light. Just like your eyes can see light, this sensor can see fire. When fire is near, sensor sends a signal to Arduino. When there is no fire, it sends a different signal. This helps Arduino know if there is fire and display the message on the screen. What is an LCD display? LCD stands for liquid crystal display. We are using a 16 by 2 LCD, which means it can show 2 lines of text. Each line can hold up to 16 characters. And the best part, we are using an I2C module, which means only 4 wires are needed to connect instead of 12. Let's connect the hardware. Step 1. Connect the flame sensor. First, connect the flame sensor to the breadboard and make connection as follows from the breadboard to the Arduino. VCC of flame sensor 5 volts on Arduino. GND of flame sensor to GND on Arduino. Out pin of flame sensor to pin 8 of Arduino. The sensor will send high or low signal to tell if fire is present. Step 2. Connect the LCD with I2C to Arduino. Take 4 male to female jumper wires and connect as follows. GND of LCD to GND on Arduino. VCC of LCD to 5 volts on breadboard. SDO of LCD to A4 on Arduino. HCL of LCD to A5 on Arduino. The LCD will show messages sent by the Arduino. Final check before uploading code. Flame sensor to VCC to 5 volts, GND to GND, out to D8. All jumper wires are firmly connected. LCD is clean and visible. Now to connect your Arduino to the computer, take the USB dumb cable and connect one end to the Arduino Uno board. Connect the other end of the USB cable to your computer's USB port. This connection powers your Arduino and allows your computer to communicate with it. Now look into the code and let's understand it step by step. Include wire.h and include liquid crystal I2C.h. These are libraries that help us control the I2C LCD. Now add this library, click on the third option in the right side menu, which is Library Manager. Here search for liquid crystal I2C and click on Install button. And now your Arduino has the special ability to control LCD with I2C. Liquid crystal I2C. LCD 0 by 27, 16, 2. This line tells Arduino, hey, I'm using an LCD with I2C at address 0 by 27. It has 16 columns and 2 rows. Pin mode. Flame sensor pin, which is input. It tells Arduino the flame sensor sends signal to it. Input. LCD begin and LCD backlight. Start the LCD and turn on the light behind it. Flame sensor pin. Digital pin D8 connected to the output of the flame sensor. Flame value will hold the digital reading from the flame sensor low or high. What happens? Configures the flame sensor pin as an input. Starts the LCD and turns on the black light. Void setup function. Pin mode. Flame sensor pin, which is input. LCD.init. LCD.backlight. LCD.set cursor 0, 0. LCD.print. Fire alert ready. Delay 2000. LCD clear. What happens? Configures the flame sensor pin as an input. Start the LCD and turns on the backlight. Displays fire alert ready for 2 seconds as an initialization message. Clears the screen before entering the loop. Void loop function. Flame value equals to digital read. Flame sensor pin. Reads the sensor's digital output. Low 0, which means flame detected. High 1, which means no flame detected. Most flame sensors work this way, but it's worth checking your module data sheet. Fire detected case. If flame value equals to low, LCD.clear. LCD.set cursor 0, 0. LCD.print status fired. LCD.set cursor 0, 1. LCD.print take action now. When a flame is detected, clears the LCD. Shows status fire on the first line. Displays take action now on the second line as a warning. Save condition case. Else function. LCD clear. LCD.set cursor 0, 0. LCD.print status safe. LCD set cursor 0, 1. LCD print monitoring. When no flame is detected, LCD shows status safe. Display monitoring to indicate the system in running normally. Delay between checks. Delay is 500. Adds a 500 millisecond delay to 0.5 seconds between each reading to prevent flickering and reduce sensor polling frequency. How it works in practice. Startup. LCD shows a welcome message for 2 seconds. Monitoring. Continuously reads the flame sensor. If flame is detected, shows a strong alert. If all is normal, displays a calm safe status. What happens overall? Arduino check if the flame sensor detects a flame. If flame is found, it shows fire message. If no flame, it shows safe. It keeps checking every 0.5 seconds. Now it is time to upload code. Before uploading, make sure you install the required library. The library helps the Arduino communicate with LCD using I2C. Uploading the code. Before you upload the code, select your board, which is Arduino Uno, and the right COM port. Click the tick to verify the code. Click the upload button to send it to Arduino. Now your LCD should begin. Now let's test the fire alert system. Being a candle or lighter near the sensor, LCD will say fire. Move the flame away, LCD will say safe. Try this a few times and observe. Summary: you just created your own fire alert system using a flame sensor and LCD with I2C. You learned how to connect an LCD using just 4 wires, how flame sensor detect fire, how to display sensor output as a message. Great job, mini engineers! Keep experimenting and building cool safety systems with Arduino.